Hello, my lovely viewers. Welcome again to Mathematics and I. It is your presenter Jefferson, and today we shall be discussing the topic known as partial variation. Now, in our previous videos, we've talked about three types of variation: the direct variation, the indirect variation, and the joint variation. So today we shall be looking at partial variation. Now, what is really the difference between this variation and the others that we've discussed so far? Now, first of all, the first thing you need to understand about partial variation is that it leads to a simultaneous equation. Now, why does it lead to a simultaneous equation? It does because it has two constants. Now, you will notice that in our previous types of variation, we only talked about one constant, which is k. But in partial variation, we shall be introducing two constants. And because there are two constants, we need to solve for these values simultaneously. And so, it leads to a simultaneous equation. So, just the way we have been doing in our previous types of variation, first of all, we look for the value of our constants, and then we get the relationship connecting the variables or the quantities involved. And after this, we can find our relationship, and then we look for every other thing that we are asked to solve for in the question. Okay, we shall be using just one example to explain partial variation, and then we are done with the class. So let us begin. Now, let us imagine we have a question like this. If x is partly constant and partly vary directly as y. Full stop. When x is 4, y is 2, and x is 2, y equals 1. Full stop. Find Roman figure 1, the relationship. Roman figure 2, the value of x when y equals to 10. Okay, now let us take a look at this question again. It says, if x is partly constant and partly vary directly as y, when x is equal to 4, y equal to 2, and when x equal to 2, y equal to 1, find the relationship. Now, you know that before we can find the relationship, we need to get the value of our constants. And from the beginning of the class, I told you that in partial variation, we have two constants. So we're going to see how it works. Now, the first thing that I'll be explaining to you guys is how do you bring out these written words in mathematical form. Now, let us begin. Now, like I said from the beginning of the class, we are going to be introducing two constants. Now, you have choices. You can decide to use your constants as m and n. You can decide to use a and b. It depends on you. Now, in this case, solution. In this case, we shall represent our constants with m and n. Let m and n be our constants. Okay, now if we are using m and n as constant, now this is what we do. Watch me. Now just follow me as I read it again. Now it says, if x, now this is my x, is, the word is represented by an equality sign, partly. Now, when you see partly, you introduce the first constant, which is m, is partly constant, and is represented by a plus sign. Partly, you see again the other partly, they introduce your other constant, which is n. Now, vary directly as y. Now, this is my y. I come again. If x is an equality sign, partly introduce your first constant and replace it with addition sign. Partly, you introduce your second constant, vary directly as y. Now, imagine this question says vary inversely as y. It means where will be our y will be down. You get it? Inverse variation. But because it is a direct variation, our y is up. Okay, now we've done that. Now, what do we start doing now? You see from the beginning of the question that the values of two values of x was given and also two values of y was given. Now let's substitute. Now the first value we have for x is x equal to 4, then y equal to 2. Now what does that mean? Anywhere I see the value of x, I give 4. Anywhere I see the value of y, I give 2. So here it becomes 4 is equal to m plus n2. Call this equation 1. Now we've gotten our equation 1. How do you get equation 2? Using the second values. Now our second value, x is 2 and y is 1. So again, we substitute in anywhere we see x, we give 2, and anywhere we see y, we give 1. So automatically, what do we have? 2 is equal to m plus n bracket 1. Let's give this in the bracket to make it make more sense. Now you call this equation number 2. Now class, once you have got your equation 1 and equation 2, you solve simultaneously. Now you choose, you subtract either equation. Either you can subtract equation 1 from equation 2 or equation 2 from equation 1, as the case may be. Now in this case, I want to subtract equation 2 from equation 1. Now let us bring it out again now. Equation 1 is 4 is equal to n plus 2 times n will give us 2n, and equation 2 is equal to m plus n. Why? Because n times 1 will give us n. Now let us subtract. Now subtracting, we have this. 4 minus 2 gives us 2. M minus n gives us 0. 2n minus n gives us n. So what does that mean? It means that the value of n is 2. Remember, n and m was not given in the question. We were the one that introduced them as a constant. So we must have to look for their values first. Now, if n is 2, what's the next constant I'm looking for now? N. Now, how can I get n? You can either use equation 1 or equation 2, any of the equations. What you just have to do is to substitute the value of n, which is 2. Okay, now let us use equation 2 to get the value of n. So I will come here now. Anywhere I see n in equation 2 now, I'll give the value of 2 there. So here it becomes 2 is equal to n plus 2. Now, what do I do here in this case? I collect like things. Now, if I collect like things, what am I going to get? If plus 2 crosses to this other place, it becomes minus 2. So automatically, what do I have? It becomes 2 minus 2 is equal to n. Now, 2 minus 2 will give us 0. So it means n is equal to 0. Now that I've gotten the values of the two constants, what's the next thing we're going to look for now? Is to look for the relationship, which is Roman figure 1. Remember, they didn't tell us to find constant, but you must find your constant before you get your relationship. Now, getting our relationship now, we have this. How do you get a relationship? This very place that you introduce the constant, that is where you get a relationship. So far, anywhere you see the value of m, you give 0. Anywhere you see the value of n, you give 2. So our relationship now is, now it becomes x is equal to, now this is m is 0 plus n, what's n? N is 2 plus 2, then what do we have here? 2y. And that becomes our relationship. X equals to 0 plus 2y. Now that we've gotten our relationship, what did they say we should find next? They said we should find the value of x when y equals to 10. Now, Roman figure 2. They said find x, meaning x is unknown, and then our y is 10. Okay, now, how do we get the value of x? It's by using the relationship now. Anywhere I see the value of y, what do I leave there? 10. So automatically the mass becomes x is equal to 0 plus 2 bracket y now is 10. So what do we do now? X becomes 0 plus 2 times 10 gives us 20, and 0 plus 20 gives us 20. So x is equal to 20. So class, this is how you work with a partial variation question. Whenever a question is given to you and it is a partial variation, the first thing you are expected to do is to introduce your constants, and I told you your constants are 2, and when you introduce your constants, the next thing is for you to do is to solve simultaneously to get the values of these constants, and after you've gotten the constants, you get a relationship, and with your relationship that has been gotten, you can solve any other question from that particular question. So I believe you have been able to learn something from today on that partial variation. So we'll meet again in our next class Always remember to share, always remember to comment, always remember to like, and please leave your comments there. Tell us how you feel about what you have learned so far, and if there are some things you also need to add to it, you can also give it there on the comment section. Till we meet again, thank you very much.